Hi, and welcome to the guided practice for lesson 10.3. This is page 320 from the textbook, and I'd like to get started with here the table shows the number of miles run by students in two classes. Use the tables and numbers 1 and 2, and this goes back to example 1 from the lesson earlier in a different video. So miles run by class 1 students. Wow, somebody ran 12 miles. And then somebody ran 1 mile. That's a big difference right there. But these are all the different miles they ran for class 1 and class 2. So for each class, what's the mean? What's the mean absolute deviation, also known as the MAD? I have all these calculations here, and I spent some time writing them out. So here, let me make this a little bit smaller and show you that these numbers right here, all these numbers are written here, and there are 15 of them. So I'm gonna run through how I did this real quick. So once again, these are the numbers of all the miles. I added them all up and divided by 15 because there's 15 numbers. Now that sum is 90, and 90 divided by 15 is 6. So that means the mean is 6. Now to get the mean absolute deviation, the MAD, I have to take that 6 here, and that gets subtracted from each of these. So it's going to be 12 minus 6, and then 1 minus 6, and 6 minus 6, and 10 minus 6, and so on. That's what I did here. 12 minus 6, and 1 minus 6, and 6 minus 6. And then the next one is, well, 10 minus 6 is here, and 1 minus 6, and 2 minus 6. Oh my goodness. There are 15 subtractions happening here because there's 15 numbers. Now, the reason why there's an absolute value symbol here is because sometimes this number is larger than 6. So 12 minus 6, that's 6. And sometimes the number that I'm trying to subtract, this 1, which came from here, the 1 minus 6, that ends up being a negative. But I don't want any negatives when I'm trying to take the average or the mean absolute deviation. I'm trying to figure out how far away is each of the data points from the mean. That's what this is. This number is 12 is 6 spaces away from the mean, which was 6 back here. So you notice 6 is all down here. 6 is here. 6 is here. 6 is here. And then all the other numbers are the data points that I have from up here. So once back to this, see 6 minus 6, that's 0. Okay, 8 minus 6, that came from one of these 8s here. That's 2. That's 4. But this 1 was, I don't know, it's probably this one right here. There's 2 ones. Oh yeah, there's 2 ones. There's 2 ones right there. So the second one right there probably was 1 minus 6. Again, negative. I don't want the negatives. I just want to know what is that average distance to the mean. And when I do all this stuff, let's see what I get here. So here, these are the distances to the mean, all the data points. That's their distance to the mean. And I take all those numbers here, and I take them again, and I add them all up, which is 46, and I divide it by the number of data points I had, which was 15. And 46 divided by 15 is about 3. So what that means is each of these data points, and I could go all the way back to the beginning. Each of these data points here, each of these data points on average is 3 spaces, their distance is 3 to the mean. The mean was 6, and on average, they're about 3 spaces away from the mean. All right. Then I did the same thing for the second data set. So all these numbers, I did some number crunching. So first off, I found the mean of all those numbers, and I got 11. And then that same process here of the distance to the mean. See, 11 is that average, and it's all here. That's the mean. And then the first number is the data points, the 11 and 14 and 11, 11, 14, 11, and so on. I went all the way down. The last data point is 15, and there it is, 15 minus 11. And then I took all these numbers, all those distances to the mean, and I took the average of that. And so I took all these numbers here and I wrote them all out, added them up, and I got 46 divided by 15, which is about 3. So let's go back to this. What was the mean? So for class 1, the mean was 6, and the mad was about 3. And then class... Oh, you know what? You know what I'm going to do? I'm going to do this. I'm going to put this in blue. So class 2, the mean is, oh, that was 11. I see it peeking out right over there. It was 11. No, was it? Yeah, it was 11. So that was 11 when I did that. And and then the mad is about, that also was, oops, that also was about 3. So there you go. So now the difference of the means is about, so the difference in the means, what was the difference in the means? The difference in the means, well, the difference in the means, we can see that class 2 had a mean of 11, and I'll do minus, and class 1 had a mean of 6. I'm just reading it from number 1, and so that difference is 5. Oh, and then so how, but it's going to be actually 5 divided by the mad to see how many times larger it is. So the mad was 3, which is about what is 1.6 repeating. So that's the answer, 1.6 repeating. So you take the difference in the means, which was 5, divided by the mad, 1.6. Okay, number 3, we have the box plot shows the distribution. Shows distributions of mean weights of 10 samples of football players from each of 2 leagues, A and B. What can you say about any comparison of the weights of the 2 populations? Box plot. Big range there. Larger box here. Lower median. Okay. Well, this is what I have to say about it. The variation of overlap makes it hard to make any convincing comparisons. So, yeah, there's a lot of overlap. These pretty much overlap. These pretty much overlap. And there's a large variation going on here. So, to compare, I mean, to say that one is a lot bigger than another one, and the medians are, somewhat comparable. When you're talking about 258 to 271, that's not that big of a difference. There's not a huge difference between the two, so it's hard to make any, like it says, convincing comparisons. So, finally, why is it a good idea to use multiple random samples when making comparative inferences about 2 populations? Well, this is what I have to say. Well, why is it good? Because we can see how statistical measures vary among different samples. Again, this other one here, there wasn't much of a variation, so it's hard to compare them. But when there is a big variation, yeah, then you can make an easy comparison. So that's the guided practice. And that's all you need to know.